All right, hi guys. Today is your first official college algebra lesson. We are jumping into chapter R, which is the review chapter, and this is going to be pretty short and sweet. We'll spend about a week and a half on this. So go ahead and you can have these slides pulled up next to you if you'd like to on your computer or tablet. These are in Google Classroom for you, or you can just follow along on the screen with me. And I would like you to grab out a piece of paper and then pens or pencils to write with. Please title your notes Lesson R1. We are learning about set notation today, and make sure that you're either doing this in your notebook or a binder that is specific to college algebra so that you can have your notes all in one place for the year. As with any other video, feel free to pause it at any point, rewind, speed it up, slow it down, anything that you need. Okay, so here this is just our objective that tells us we're going to demonstrate knowledge of set notation by the end of this. And here is our warm-up. So I would like you guys to go ahead and pause the video, take a minute to answer these questions, then you can come back and check your answers. So looking at this, it says complete the statement using a less than, greater than, or equal to symbol. So we're comparing 1.3 to 1.03. 1.3 is greater than 1.03, so I'm going to write it that way. And then we're comparing 5/8 to 7/9. Now, one of the easiest or quickest ways to compare this is by making these into decimals. So if I divide 5 by 8, if I plug that into a calculator or my phone, I'm going to get 0.625. And then if I plug in 7 divided by 9, I'm going to get 0.7 repeating. So which one of those is greater? The 7/9 is greater, so that's going to open up towards it. Inequality always opens up towards the larger value. Okay, what is the name of this symbol? This is the less than symbol. We read it left to right. And then this symbol is the greater than symbol. So we just used both of those. All right, next slide. So some key vocab that you need to know is the difference between an equation and an expression. This is something that students can mix up pretty frequently and easily, so it's really important going into this year that you know what these two mean. So an equation is when you have two expressions, but they are set equal to each other. So the key thing here with an equation is that it has to have an equal sign in the middle or somewhere in it. Okay, an expression, that is just a collection of constants, which means just numbers that don't change, variables, so x's, y's, z's, and arithmetic symbols, so like plus, minus, multiply, divide, exponents, all of that. Okay, so an expression here would just be a 9x. There's no equal sign there. There's nothing to solve. It's just an expression. It's by itself. Okay, two other vocab words, finite versus infinite. Finite is something that has limits or bounds, or it is a countable amount. So like the money in my bank account would be an example of this, okay? I wish that I could say I have an infinite number of money in my bank account, but unfortunately I do not, okay? It's something that I can count. Infinite, you guys probably know, are familiar with that. Infinite is something that has no limits or no bounds. It cannot be countable, okay? So it goes on forever and ever and ever and ever. All right, inequalities. An inequality is like an equation, but the key thing here is instead of having an equal sign, it has one of these symbols. So please go ahead and write these 4 symbols down. Again, you can pause the video, take your time. This is the less than symbol. We've already looked at that. This is the less than or equals to symbol. So if it has the equals to sign below it, then this is the greater than symbol, and this is the greater than or equal to symbol. You guys might remember when you first learned inequalities in pre-algebra or in middle school, your teacher might have compared an inequality symbol to the mouth of an alligator or a shark, and it's really hungry, so it's going to open up towards the bigger piece of prey or bigger piece of meat. Okay, so that's a way to kind of remember the order of it. All right, so here's some examples of inequalities. Again, pretty basic reminder, but just to just to refresh your guys' brains on this. So if we look at x is less than 5 right here, this means that whatever value x has, it must be less than 5. So on a number line, here's 5. It cannot equal 5, so there has to be a hole there. It's not an actual point. And then the line points to the left of 5 because it can be anything less than 5. So 0 is less than 5, -5, 1, all of those numbers to the left are less than 5. Okay, here's another example. X is greater than or equal to 2, so this is opening up towards x, which means it's greater than or equal to. So if it can equal it, there can be a point there, and then it's going to point to the right because all the numbers to the right of 2 are bigger than it. So 2, 3, 4, or sorry, -2, 0, 1, 2, all of those are going to be greater than -2. All right, set notation. So here's the new stuff for most of you guys. So a set is exactly what it seems like in math. It's similar to what we call a set in normal life. So a set is any collection of objects. Usually in math, it's going to be numbers. So it's a collection of numbers. Just like you might have a collection of Converse, or you might have a collection of whatever it may be, something that you love. Okay, for sets, we use capital numbers to name the sets. So it's more formal, it's a capitalized thing. And then an element is one of the items within the set. And we use lowercase numbers or letters to represent those elements inside of the set. So if I say I have a set of shoes in my house, then one of those shoes, let's say my ballet flats, that would be considered an element within my set, my overall collection of shoes. Okay, here's the format for set notation. You do not need to write all of this down. I would like you to at least write this box on the left down, just for you guys to see this example. Okay, so as you see here, in set notation, each one of these has an inequality within it. Okay, so this one here says x is between 1 and 3, and it can include 1. So it's greater than or equal to 1. This is that side of the inequality, and it's less than 3. That's the right side of the inequality. Now, the only thing that's different about this is writing it in a set, we have these curly Q brackets. Okay, that means we have a set here. And then we also have the x, the first x there, and the bar. And what that means, here, let me draw an arrow. Okay, this bar and this x means the set of all x values such that x is, like we said, greater than or equal to 1 and less than 3. Okay, so the set of all x, that's the bracket and the x right there, such that is this line. So such that is the line. And that's a little bit hard to see in blue. Okay, so that's all that the bracket, the curly Q brackets, and the line mean. So we'll continue to see some more examples, and that will hopefully sink in and make a little bit more sense. Okay, so set notation procedures. We write all members of a set within the curly Q brackets like I just showed you, and you're going to use commas to separate every single element. So like you would list something if you're writing a paper about something and you're listing things out, you separate them with commas. Okay, you also use ... to mean so on and so forth. So if the pattern continues and it goes on and on, you're going to use ... All right, so here's a very basic example. If we have a set of numbers that include 5, 7, and 11, we can write that with these curly Q brackets around them and commas separating each element. Okay. Here, this is just a link or a URL to some more information on set builder notation if you need to go back and look at that. Here's some more examples of sets, so please write these down. So here is a finite set. The set of the numbers 1, 2, and 3. The reason that it's finite is because it only has these 3 numbers. It can be counted. We're not adding anything to it. All right, this is another finite set. 1, 2, 3. There's this dot, dot, dot in between, okay? But once we've established the pattern here, you can see it's just talking about the positive integers. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and then 10. So it's ending at 10. We know it doesn't continue going on forever. This dot, dot, dot just tells us that there's a 4, 5, 6, 7, 8 inside of there, and it makes it a little bit easier. Okay, so both of these are finite sets because they end. Now this one, on the other hand, is an infinite set because it's 1, 2, 3, dot, 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 meaning it goes on forever and ever and ever. You continue to count the whole numbers, 3, 4, 5, 6, 7, 8, etc. Also, an infinite set right here is the set of all x values. Here's the line, such that x is greater than 5. Well, there are an infinite number of numbers that are greater than 5. 6, 7, 8, 9, 10, blah, 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 all those whole numbers, but also all the decimals, 5.1, 5.012, 5.12567, etc. Okay, so that goes on forever and ever. All right, here is another example of set builder notation format and some other ways that we can write it. So we're always going to have these curly Q brackets like we said, and then you're going to have whatever variable you're talking about, the line that says such that, or that means such that, and then the description of the set, okay, and then you end with curly Q brackets. So here's an example without math. So the set of all x such that x is a living United States president, okay, that could be one set. Here's another example, the set of all x such that x is a digit. So a digit would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, the digits that you can count on your hand or your fingers. All right, a couple other rules for set builder notation. We do not list any element more than once because the elements, we consider them distinct. So even if I have a set of numbers and one appears twice, it does not matter when I'm listing the elements in the set. I'm only going to list it once because once I've listed it once, it's accounted for. Also, order of the elements does not matter. So if you look at this, for example, the set of the numbers 2 and 3 is also the same thing as the set of the numbers 3 and 2. The order does not matter. So we don't repeat elements and the order does not matter. All right, last slide here. The empty set or the null set is when the set contains no elements. Okay, so there is such a thing as the empty set or the null set, and these are the two symbols to represent them. So it's like this circle with a slash through it. That means there's nothing in the set, or you could write the curly Q brackets without anything in them because that means the set is empty. Okay, so that is all that you need to know for today. You guys can go ahead and get working on your first assignment, which is your R1 worksheet, and that is also linked on Google Classroom.